Now let's continue our function on the graphs. Okay, now let's take a look at section 1.2. I want to talk about graphs of equations. And we have four major learning objectives. First one, sketch the graph of equations. Second one, identify x-y-intercept of graphs of the equations. Third one, using the symmetry to sketch graph of the equations. The fourth one, we learn how to write equation and sketch graphs of the circle. First of all, let's take a look at a graph of the equation. Typically, equation look like one of the equation could be mx plus b. So this is what we call linear equation. We also learn the quadratic equation. ax squared plus bx, adding c, quadratic equation. Okay, those two are the most popular ones. So we're using coordinate system, Cartesian coordinate system to graphically represent a relationship between the two quantities. Here we also call two variables. Typically we're using x and y, right? X variable and a y variable. And the graphical picture consists of the collection of points in the coordinate system, coordinate plane or Cartesian plane. Basically, this equation representing the relationship between two variables. So we call this equation in two variables. For example, let's say y equals 7 minus 3x is the equation expressing the relationship between the x variable and the y variable. And order pair AB is a solution or solution point of the equation. And when replacing x equal to a and then y equal to b, you come up with a true statement. Okay, because both a and b satisfy this equation. Okay. For example, let's say let's pick point 1, 4. If you replace x with 1, y with 4, then we come up with the true statement here. So x goes in here, y goes in here, and you get a 4 equals 7 minus 3 times 1, and this is a valid statement. Also, you can say it's a true statement. That means 1, 4 is a solution for this particular equation. And we're going to start learning some basic procedure for sketching a graph of the equation in two variables. Okay. Usually, we just come up with this sets of points, and then we just graph it using either smooth curve or smooth line. Okay. So basic technique used for sketching a graph of the equation is called point plotting method. So you come up with the point plotting method of graphing. First of all, possible isolate one of the variable. You can also say that get y by itself, get y variable by itself. That's how we isolate one of the variable, and then construct table values showing several solution points. So basically, you come up with the several order pairs from equation. Then the third step, plot those points in the rectangular coordinate systems, and the fourth step, connecting the points with a smooth curve or line. Okay, and typically we're using some negative values when we come up with the x coordinate. Use some negative values, 0 or positive values for the x coordinate when we start creating a table. Okay, so now let's take a look at this. Let's say we have a equation y equal -3x plus 7 as we mentioned earlier, we're going to create a table first. We come up with the xy coordinate. Here, let's have some negative values and positive values. Let's say we want 5 order pairs, starting with -2, -1, 0, 1, 2. Okay. And we're putting this sequential order. Okay. And then next step is come up with the y coordinate. So here, first y coordinate will be -3 times -2, adding 7. Turn out to be multiply that, you get 6 plus 7, that's 13. Okay. Second one, y equal -3 times -1, adding 7. That turn out to 3 plus 7, which is 10. Okay, and the third order pair, y equal to -3 times 0 plus 7, 0 plus 7, that's 7. Okay, let's put in the numbers. 7. Fourth order pair, -3 times 1, adding 7. So -3 plus 7 turned out to be 4. And last order pair, y equal to -3 times 2 plus 7, which is -6 plus 7. And that is +1. And we basically come up with the 5 order pairs, and next step we just have to plot those order pairs in the Cartesian system and come up with the graph. Okay, so we basically each one translated into order pairs: -2, 13 first order pair, -1, 10 second order pair, 0, 7 third order pair, 1, 4 fourth order pair, and a 2, 1. If you look at x value increase by 1 unit, y value go down by 3 units. And you form a pattern here. You know, anytime when you're increasing the x value by 1 unit, y value go down by 3 units. And you can think about why that happens. Okay, but next step is start plotting this. Okay, so we can just plot it right here. Start with the more positive side of the line. So let me just modify a little bit right here. So x-axis origin and y-axis. So now for the x coordinate, smallest value is -2. For the y coordinate, smallest value is 1 all the way to 13. So we need 13 units: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 should be sufficient. Okay, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Now once you have all those, take into account of the minimum value and maximum value on both x-axis and the y-axis, you start plotting this. So first one is -2, 13. Right, so go all the way to the top. Second one, -1, turned out to be 10. Yes, right here. 0, 7. 1, 4. After that is 2, 1. Okay. And as you can see, this is a linear equation. So if you're connecting those 5 points, you get a line, right? So yeah, here we go. That's how basically plotting all those 5 points, connecting them, extending in both directions. Then we get a equation of y equal -3x adding 7. Okay. And that's how you typically draw up any equation. And for linear equation, 2 points is more than enough. Here we come up with 5 points, which is even better. More points meaning more accurate graph. Okay. And next topic is intercept of the graph. So it's very easy to determine the solution points of 0 as either the x coordinate or the y coordinate. These points are called intercept. So intercept is when the graph of the equation meets with the x-axis or y-axis. So the graph intercept or touches the x-axis, y-axis. That's generally what we call the intercept. The graph meets with x-axis or y-axis. Okay. And it's possible for graph to have no intercept, maybe one intercept or several intercepts. First of all, let's look into each scenarios. First one, if you look at it, look like a parabola. It has no x-intercept, right? The graph doesn't meet with the x-axis, but it does meet with the y-axis once. Okay, so we have a y-intercept here. No x-intercept. And the second one, 3 x-intercept. You see 1, 2, 3, 3 x-intercept. And since origin is counted as both x-intercept and y-intercept, so in this case it has one y-intercept. So origin is counted both as a x-intercept and y-intercept at the same time. Is both x and y-intercept. It's a very special case if you have an intercept and in the origin. Okay, the third case we have 2 y-intercept, 2 y-intercept, and 1 x-intercept. This is x-intercept. Then we have a couple y-intercept. Last graph is a circle. It doesn't touch x-axis or y-axis, so we call this no intercept. This one typical no intercept. And typically, for simplification reason, you can just put x-intercept as order pair a comma 0, and the y-intercept as order pair of 0 comma b. So that means for x-intercept, y value is always 0, right? For the y-intercept, x value is always 0. So this is a very crucial aspect of both intercepts. So now some textbook, the x-intercept is x-coordinate of the point a comma 0, and the y-intercept is y-coordinate of the point 0 comma b, rather than the point itself. So for x-intercept, you can just write it as x equal to a. Y-intercept, in this case, you can write it y equal to b. Okay. You just use a coordinate instead of point itself. Also, intercept refer to both either the point or the coordinate. So you either have using the point, that's a comma 0 or 0 comma b. Okay, or you can just use coordinate just like the x equal to a. And these two are equivalent, and y equal to b. Again, these two are equivalent. And let's learn how to find the both intercepts. To find x-intercept, set y equal to 0 and then solve for x. Set y to 0 and solve for x value. Okay. And for finding the y-intercept, set x to 0 and solve for y. Okay. Now this is a simpler version of the how to find the x, y-intercept. Okay, so now let's take a look at this. Let's find the x-intercept. Could be multiple intercepts, x-intercepts here of the graph y equal to x to the third minus 4x. So in order to find x-intercept, in this case we have multiple of them. So we will need to set y equal to 0 and then solve for x. So here when y equal to 0, go back to the original equation. We get 0 equal to x cubed minus 4x. Now let's reverse order. X cubed minus 4x equals 0. Then we can factor by GCF. X is the GCF. We get x squared minus 4 equal to 0. So we get three solutions. First one is x equal to 0. Second one is x squared minus 4 equal to 0. And we can use quadratic formula, adding 4 from both sides of the equation. Let's get first 0 right here. So we get x squared equal to 4. Now we're taking the radical from both sides of the equation. When we're taking the square root, plus minus on the right hand side. So x equal plus minus 2. Okay. And basically we have three x-intercept. So if you want to list it, those three x-intercept will be 0, 0. And second one will be -2, 0. And the third one is 2, 0. Okay, three x-intercepts in this case. As you can see from the graph, we have three x-intercepts, 1, 2, 3, there you go. And that's how you find x-intercept for any given equation. Key thing is setting y equal to 0, solve for x. Now, let's take a look at how we find the y-intercept. And again, in order to find the y-intercept, we're setting x equal to 0 and solve for y. So here, when x equal to 0, it goes here, it goes here. Okay. So the y value equal to 0 cubed minus 4 times 0, and this turned out to be 0 minus 0, which is 0. That means we only have one y-intercept, which is 0, 0. Okay. As you can see, and the origin is only y-intercept here. And origin is both x and y-intercept. Okay. And then next topic, let's look at the symmetry. So most of the graph may have a symmetry, so you need to learn how to identify the symmetry. Graph of equation could have symmetry. Symmetry meaning they form a mirror image based on a certain axis, or could be origin. Symmetry with respect to one of the coordinate axis, meaning x-axis or y-axis. They could have a symmetry with respect to the origin. So symmetry with respect to x-axis meaning look at the following graph, right? This graph right here. So the graph form a mirror image based on the x-axis, form the mirror image. Based on x-axis. And you can also look at this way if you fold this graph. You fold it, you will see the fold based on x-axis, they will match exact same location. Okay. So you can look at it from different perspective. I think mirror image give you a better understanding. When you fold it, it becomes a mirror image. If you look at the symmetry with respect to x-axis, at any given point, let's say on the top of the graph xy, you can always find the symmetry point with the same x coordinate here. So this is same x coordinate, but the y coordinate becomes opposite. Okay. So the important thing about the symmetry with respect to x-axis is x remains the same, but the y value becomes opposite. Okay. And both points are on the graph of the equation. And symmetry with respect to y-axis, meaning they form a mirror image based on the y-axis. So for the y-axis, the y value is the same, okay, and the x value becomes opposite. So as you can see, y value remains the same, but the x value becomes opposite. And we also have a symmetry with respect to origin. Origin is right here. So this point right here, x comma y, becomes exactly opposite for the mirror image with respect to origin. So xy becomes negative x and negative y. And knowing the symmetry of the graph before graphing it, it's really helpful. Give you a direction, also a rough idea, where the graph should be located. So that's why knowing the symmetry is kind of useful. And we have three basic type of symmetry. We'll just talk about symmetry with respect to the x-axis. As you can see, y becomes negative y, right? X remains the same, y value becomes opposite. Symmetry with respect to y-axis, x value becomes opposite. X becomes negative x, y remains the same. And the symmetry with respect to the origin, both x, y becomes opposite. So that's how basically how those three symmetry look like. You look at it from a graphical perspective. And now let's take a look at this. So we have equation y equal to x squared minus 2. It's proper, so basically it's symmetric with respect to the y-axis. But we could prove this. As you can see, you can just come up with the order pairs. Let's list 6 order pairs. Okay, so now if let's say we're picking the x value from -3, -2, -1, and then 1, 2, 3. As you can see, those values are opposite. So now let's first look at the first group. When x equal to -3, then y value equal to replacing x with -3, so -3 squared minus 2. So it's -3 squared is 9 minus 2, turn out to be 7. Okay, so now let's look at the positive 3. Replace x with positive 3, so we get 3 squared minus 2, which is 9 minus 2. It's also 7. As you can see, we have opposite x values, but the y value are the same. Okay. Similarly, with the -2, y equal to -2 squared minus 2. So that's 4 minus 2, turn out to be 2. Okay, so the y value is 2. When x value equal to -2. When x value equal to positive 2, it will be 2 squared minus 2, turn out to be 4 minus 2. That's also 2. So similarly, the y values are the same with the opposite x values. You can also verify that when x equal to -1, -1 squared minus 2, which is 1 minus 2, -1. Okay. Then when x value equal positive 1, so it's 1 squared minus 2, 1 minus 2 is also -1. Okay, similar. Again, they are the same. Opposite x values, same y values. Now we can easily verify that through the graph. So you see this symmetry point, corresponding symmetry point with the same y values, but opposite x values. And that's what we call a y-axis symmetry. If you look at it from a graphical perspective. And we can also prove a symmetry using algebraic tests. So the graph of the equation is symmetric with respect to the x-axis when replacing y with negative y. Y becomes negative y. Yields the equivalent equation of the same equation. The graph of the equation is symmetric with respect to the y-axis when replacing x with negative x. Yields the equivalent equation. The graph of the equation is symmetric with respect to the origin when replacing x with negative x and y with negative y. Yields the equivalent equation. Okay. Now let's take a look at how we sketch the graph for y equal to absolute value of x minus 1. And first thing is, let's test those three symmetries. First one is x-axis symmetry. See if there's any symmetry here. So for axis symmetry, replacing y with negative y, so you yield the same result. Replace y with negative y. The key thing is to get the same equivalent equation. So y becomes negative y, the absolute value of x minus 1. And if you get y by itself, multiply both sides of the equation by negative 1. So negative 1 times negative y. On the right hand side, similarly, times negative 1. Negative 1 times negative y, and that's positive y. So negative absolute value of x minus 1. So we do not yield the same equation, or the equivalent equation, we yield the opposite equation. So there's no x-axis symmetry. And the second one, let's take a look at the y-axis symmetry. So for y-axis symmetry, replacing x with negative x. So y value equal to absolute value of negative x, x becomes negative x minus 1. As you can see, they are not the same. So it's not the same as the original equation. It does not yield the equivalent equation, so there's no y-axis symmetry. And for the symmetry with respect to origin, I'm going to replace y with negative y, x with negative x. And will turn out to be negative y, the absolute value of negative x minus 1. And again, get y by itself, end up with y equal to negative absolute value of negative x minus 1. Again, it's not the same as the original equation, so there's no origin symmetry. No symmetry with respect to origin. That's how we check all three different symmetry, basic symmetry using algebra. And if you want to graph this, plot connecting the points, you could just pick some x values. Pick some x values on top. And I'm going to show you how to get one of them. So let's say you're picking x equal negative 2, and you're plugging negative 2 into the equation itself. So y equal to absolute value of negative 2 minus 1. Minus 2 minus 1 is minus 3. Absolute value of negative 3 becomes positive 3. So end up with the order pair, which is negative 2 and 3. The same idea, you can get the rest of the points. Second one, x equal negative 1, so we get y equal negative 1 minus 1. Y equal to absolute value of negative 2. Absolute value will turn into positive 2. Y equal positive 2. So here we get second order pair, -1, -2. And one more point, when x equal to 0, again plug into the equation y equal to absolute value of 0 minus 1. That turn out to be -1, absolute value of -1, it's +1. So everything comes out of absolute value sign will become positive. Okay, that's key principle for absolute value symbol. Yeah. So we get all these order pairs, and if you plot it, you get this the graph of the equation. As you can see, actually, there's a symmetry here, and symmetry turned out to be x equal to 1. Okay. If we really want to find a symmetry, in this case, the symmetry here is x equal to 1. And the way how we find it is by setting x minus 1 equals 0 and solve for x. But yeah, and as you can see, we have a couple intercept. Okay, so the y-intercept is 0, 1 right here. This is y-intercept. So we have both x and y-intercept. X-intercept is right here, 1, 0. And the interesting thing is it's symmetrical with respect to the x equal to 1. And this is not a regular type of symmetry, but it's kind of special. Okay. The last topic in this section is on the circles. Okay. So typically the circle will look like this, has a center. Two important things about circle is the center and then the radius. Center, center, radius. So typically center could be using h, k. We typically use h and k represent the center. Radius we're using r to represent the radius. HK is the center and radius. And the circle is defined by measuring the center and every point on the circle. So basically, we assuming every point on the circle is x, y. So we're using distance formula to capture the radius here. So we're using distance formula. So this is x1, y1, and this is x2, y2. Then so we do x2 minus x1, x minus h squared, plus y2 minus y1, which is y minus k squared, and which is equal to the distance, which is radius. So, and then you square both side equation, you'll be able to get the standard form of the, so you square both sides. So you get x minus h, parentheses square, plus y minus k, parentheses square, equal to r square. Okay, so by squaring both sides, we get standard form the equation of the circle. Okay. So, that's basically we utilize the distance formula, and also the constraint on this particular graph is the radius remains the same, right? Radius from the center and then any point on the circle is r, remains the same. So the standard form of the equation of the circle. The point x, y lies on the circle of the radius r and the center hk, if and only if x minus h squared plus y minus k parentheses square equal to r squared. And you can also see that standard form of the equation of the circle with center origin if h equal to 0, k equals 0, then we get x squared plus y squared equal to r squared. And here both hk become 0. Okay. Yep, so this is what we call a circle with a center at the origin. And let's take a look at the example. The point 34 lies on the circle whose center is at -1 and 2, as shown in figure and below figure. Right, write the standard form, the equation of the circle. So right here we know the center. Okay, hk is given. And next thing is just find out this radius. Radius is not known yet. So we just use distance formula to find radius. We can label this x1, y1, x2, y2. So the distance, which is radius, equal to y2 minus y1 square plus x2 minus x1 square. Okay. And we could just plug in numbers here. So it's square root of 4 minus 2 square plus 3 minus -1 square. So this turned out to be 2 square plus 4 square, and this is 4 plus 16. This turned out to be radical 20. Obviously we can simplify this, but it's better not to simplify at this moment. So we keep it as radical 20. So now we know the center, we know the radius. Okay, and we'll be able to write the equation of the circle, right? So x minus h parentheses square plus y minus k parentheses square equal to radius square. So h goes in here, k goes in here, radius goes in here. So you get x minus 1 square, or minus -1 square. So here be careful about the sign, because h is -1. So you also need to account the sign here. Y minus 2 square equal to the radical 20 square. So this is x plus 1 square plus y minus 2 square equal to 20. Then we come up with the equation